We have this question. An object of mass 50 kg is placed on an inclined plane at 30 degrees to the horizontal. The height of the inclined plane is 250 centimeters and its length is 500 centimeters. Question number 1. What work is done in moving the object down the plane? Question number 2. Find the work done against gravity. Now, for you to answer this question correctly, you have to be familiar with forces acting on objects that are placed on an inclined plane. So let me use this and illustrate what this question looks like. So this is our inclined plane, and then this is the angle of inclination. From the question, we are told that it is 30 degrees, and then you say that an object of mass 50 kg. So this is the object of mass 50 kg. Then the height of the inclined plane is 250 cm. So this is the height of the inclined plane. We are told that it is 250 cm. So this is 250 cm. If you convert it to meters, that's if we divide 250 by 100, we are going to get 2.5 meters. And its length is 500 cm. So it means that from this point to this point is 500 cm. So this is 500 cm. If you convert it to meters, that's 500 divided by 100. It's going to be 5 meters. So we have to find the work done moving the object down the plane. Now, this is an inclined plane, and for this object to be resting on this inclined plane, it means that the weight of this object will be acting downwards. So the weight of this object is acting downwards. Let me call it W. That's the weight of this object. It's acting downwards. And then there's a normal reaction that is acting on this object by this surface, and then this normal reaction is preventing this block from sinking into this inclined plane, and then that normal reaction is acting upwards. So this is normal reactional force acting upwards, and so the weight of this object that is acting downwards is not perpendicular to this plane. That is, it didn't make an angle of 90 degrees to this plane, and so because of that, we are going to resolve it into horizontal and vertical components. So this is going to be the vertical component of this weight, and then this is going to be the horizontal component of this weight. And then know that this horizontal component is parallel to this plane. So any value we got for this x is going to be parallel to this plane. So let's resolve this weight into its horizontal and vertical components. So we have angle 30 degrees here. So this angle here is going to be 30 degrees. So if you want me to prove it, you tell me in the comment section. Let me prove it in a separate video. This is x, then this is our angle 90 here. Please don't mind this diagram, it's not that perfect. How do you find the values of x and y? So let's use our knowledge in trigonometry. So we have SOHCAHTOA. So this is the hypotenuse. Remember, hypotenuse is the longest side of the triangle, and then this is the adjacent. Also, adjacent is the side that bears the angle of the inclination, and then the right angle triangle. And then x is the opposite, that's the side that is facing the angle of interest. Remember, we're going to find the value of this x and y with respect to this hypotenuse. So this x, which is the opposite, is associated with hypotenuse. So x is associated with opposite and hypotenuse. Now in this SOHCAHTOA, which of these do we have opposite and hypotenuse present in? So the answer is sine. This is opposite, this is hypotenuse. So we write sine theta is equal to opposite over hypotenuse. Then this is equal to, from this diagram, our opposite is x, then over our hypotenuse. So this is hypotenuse. Our hypotenuse is equal to the weight of this object. All right, so it's equal to the weight of this object. So this is the weight of this object. Now for us to find the value of x, we have that x is equal to, if you cross multiply, it's going to be equal to w sine theta. So the value of x is w sine theta. So in the same way, y is associated with the adjacent and hypotenuse. And so from this SOHCAHTOA, we have cos here, which is adjacent and hypotenuse. And so we write cosine theta is equal to adjacent over hypotenuse. That is adjacent over hypotenuse. So this is equal to, our adjacent here is y. So this is y over hypotenuse is w. So when you make y the separate formula by doing cross multiply, we have that y is equal to w cosine theta. So our x is equal to, now what is this w? This w is weight of this object, and it is given by mass times acceleration due to gravity. So this x is equal to mg, then we have sine theta in this question is 30 degrees, so sine 30 degrees, and then y is equal to w is the weight of the object, which is given by mass times acceleration due to gravity, then times cosine 30 degrees. Now this line of force here, which is y, is going to be equal to the mg cosine 30 equal to mg cosine 30, and then the x is going to be equal to mg sine 30. And so, like I said earlier, this x here is parallel to this inclined plane, so we are going to have a force that is acting downwards here as mg sine 30, and then this one here is acting downwards as mg cosine 30. Now let me redraw this diagram and show you a clear picture of what we've gotten so far. So this is the inclined plane here, yes, and then this is the object. So this object has a weight which we say that it is equals to mg, and then this is the normal reaction that is acting perpendicular to the plane and is acting upwards, and then this is the y component of this weight force acting downwards, and the value is mg cosine theta. That's the value of y that we found, and then we have the value of x as mg sine theta, which I said that is parallel to the inclined plane, and so this is how it is going to be. So this is mg sine theta, and remember we have 30 degrees here, so this theta is going to be 30 degrees, then this theta again is going to be 30 degrees. And also don't forget that we still have the length of this inclined plane, that is from here to the place that the object is placed as, so that is equal to 5 meters, and then we have the height of this inclined plane as 2.5 meters. So let me delete this one and then move this one up. So this is the clear diagram of this question. So I asked to find the work done in moving the object down the plane. Now we have this force pointing to the left hand side, and then the one coming down. So this force here now can be taken as the gravitational force, but not the whole gravitational force. Now this mg is the whole gravitational force that is trying to sink this block, that's trying to push it down. Then this mg sin theta is the portion of it. Remember, we resolved the weight of this object into its vertical and horizontal component, and so this weight of this object is also acting as the force of gravity on this object. So a portion of it is this mg sin theta, and then another portion of it is this mg cosine theta. But between these two forces, mg sin theta and mg cosine theta, which of this is causing this object to slide down this plane? So is this mg sin theta, and that is the force we are going to be using. And so the force that is causing motion on this inclined plane is equal to mg sine theta. And so when we ask to find the work done in moving the object down the plane, so remember this object moved from point A to this point, and so we are given the distance as 5 meters. So the work done is equal to force times distance, then equal to the force is mg sine theta, so mg sine theta, then multiplied by distance. So work done is equal to mass of the body is given as 50 kg, then times acceleration due to gravity 9.8, then times sine theta is equal to 30 degrees, 30, then times distance, which is equal to 5. So if you point this in your calculator, you're going to get the work done as 50 times 9.8 times sine 30 times 5 equal to, is going to be 1225 joules. So this is the work done in moving the object down the plane. So the second question said find the work done against gravity. Now gravity is associated with height, alright, so we're going to find the work done in raising this object from this point A to this point B, alright. So we're going to use this 2.5 meters because the first time we used this 5 meters because it's required to find the work done in moving the object down the plane. So here we are going to use 2.5. because gravity is associated with height. So instead of writing 5 here, we're going to replace this 5 with 2.5. Alright, so let me write it here. So work done is equal to, we have 50 multiplied by 9.8 multiplied by sine 30 multiplied by 2.5. So this is going to be equal to 612.5 joules. Alright, so and then this is the answer for question 2. So thank you for watching. Remember to follow for more videos.